All right, hello everybody, and welcome to the second webinar of the NUTRI-KNOW webinar series on livestock farming. My name is Daniel, and I'm from the European Science Communication Institute in Germany. I'm the communication officer of NUTRI-KNOW. Today we have three speakers lined up for you. And feel free, if you have any questions, to use the chat or the Q&A functionality of this webinar. I will closely monitor it. And then after the presentation, which should be about 30 minutes, we have time for your questions. Having said that, I now give over to Giuseppe, who will give an introduction to the webinar.
Okay, good morning. I'm Giuseppe Moscatelli, a researcher involved in the environmental department of CRPA, Research Center on Animal Production. The CRPA institution is located in Reggio Emilia, in the Emilia-Romagna region, in the north of Italy. The Emilia-Romagna region is an area with a high livestock intensity, situated in the Po Valley. And so the CRPA was engaged with operational groups involved in the correct nutrient management value chain in the NUTRI-KNOW project, and is the lead of this webinar about the first step in the NUTRI-KNOW agro value chain, where innovative solution and good practices for a circular and more sustainable nutrient management could produce environmental, social, and economic benefit to the agricultural sector, particularly for the livestock farming. In fact, livestock farming is the first step of the nutrient management in the agricultural sector. In the following weeks, the project will lead other webinar about other steps of the nutrient. So today, livestock is an important sector for the European economy. In fact, in the European are breeding 130 million of pigs, 75 million of bovine, 59 million of sheep, and 11 of goats. And moreover, the European Union is one of the world's largest poultry meat producer and eggs producer, with respectively 13 million of tons of poultry meat and near or less 7 million of tons of eggs. All this, coupled with the fact that the future of livestock farming and its environmental and social sustainability are under discussion in this time, and adding that the livestock is a complex system where nutrient management is not alone, but has to be integrated, related to other challenges, has environmental impact, human and animal health, animal welfare, social sustainability, and why not also the food security for the future. And all these topics make the livestock farming a crucial steps where innovation and knowledge are needed for a good nutrient management for the future compared to the past. This webinar related to the livestock farming book is the first book of a series of the NUTRI-KNOW project, offers an overview of the EIP Agri operational groups involved in the NUTRI-KNOW project that have produced innovation to reduce ammonia and greenhouse gas emission during the breeding phase, or to improve animal welfare, or to reduce nutrient losses to the environmental, as nitrogen and phosphorus, or reduce the carbon footprint of the livestock. Today, we will be presented the outcomes from NUTRI-KNOW engaged operational groups to support a more sustainable livestock system. These outcomes are derived from 4 operational groups, and particularly thanks to Ferticop, we will speak about a tool to evaluate the environmental benefit of reducing emissions by applying different best available techniques, the BAT, derived BAT conclusion, and regarding the BAT document and the breadth of intensive rearing of poultry and pigs. Thanks to gas loop, we know a pilot that was designed and implemented as a BAT technologies to reduce ammonia in pig stable and increasing animal welfare. Thanks to bioraffinery glass, an innovative bioraffinery that converts freshly harvested grass into feed for cattle and pigs, improving nutrient efficiency and reducing the carbon footprint of the livestock with new feeding sources. Thanks to the last operational group involved this morning, the Duncannon Blue Flag Farming and Community Schemes, this operational group developed and demonstrated is very important for the operational group, also then develop, demonstrate too that the good practices can be applied to the livestock farming and moreover. And the Duncannon Blue Flag developed an effective model to restore, protect, and enhance water quality, and also to foster positive relations between farmers and household. Now I stop here and give the speak to Marius Simmons from FCAC.
Hello, good morning. I am Marius Simon, that I am manager of projects of innovation in FCAC, that is an association with cooperatives in Catalonia. Ferticop was an operational group where I was the coordinator, not the technical coordinator, but a kind of coordinator that is in care of that have the success of the project in the concepts, mainly in the funding, to obtain the funding of the project. But at the end, I was following up the project. So I make some short introduction about the project, that the objectives was the challenge to shift towards more sustainable livestock systems. So Ferticop was an operational group mainly to execute pilot tests. The pilot test was led by a technical or research center that was IRTA. That is a research center located in Catalonia. So at the end, it was like a consortium, an operational group is like a consortium. Even we can compare like for other kind of project in Horizon, European Horizon, but obviously are short and very little. So also about the budget. Then the project lasted 3 years. I have to remember that the project was executed during the pandemic of Corona. That was difficult. And the project have 7 activities, or work package, we can say. And I have to put in consideration that the project in the operational groups that we are involved, not always all easy to have results from test and to have in a final report, final technical reports, but also we have intangible results that are related to know-how sharing and to establish networking between companies, between obviously with farmers and with cooperatives and with a lot of institutions. So the little projects, in fact, have a lot of impacts that can be get some good results. Some relevant objective of the projects was to reduce GHG and ammonia emissions by optimizing fertilization and innovative measures in livestock manuring management. Mainly sustainable and precise systems to improve the livestock in the farmers. Also, mainly in this part, the people involved in this part was the cooperative's technical advisory staff, not very directly the farmers. Please, Daniel, the next one. So, as I said, this kind of project not was only to execute tests, but we had a lot of visits, technical visits, and also we had conference, and we had obviously a lot of meetings to execute the project. Daniel, please, the next one. I choose only two activities to comment because I feel that they are more relevant, but also obviously someone can have a different opinion. But I think that, for example, activity 2, that was to test and develop quick methods to estimate the chemical fertility of agricultural soil in extensive crops of wheat and maize. We make a lot of tests and evaluation of quick methods in order that the advisory staff of the cooperatives and the farmers know the nutrients level in their fields. So in this activity, the level of precision should be sufficient to classify the soils into different levels of nutrient content, leading to establishment of various recommendations for fertilization. That is the important. We need recommendations for fertilization because farmers are in stress about the compliance, about rules from the administration, from the government. So it's need to have a fast response, not to wait the result of a laboratory. So we need to screening results. Next one, please, Daniel. At least we check 4 or 5 devices. There was commercial device, and all these devices are different. Some one are better to use in the field by the farmer, but other are maybe better to be used in the cooperatives facilities. At the end, we had some good results about the relate to the results obtained in the laboratory. Please, the next one, Daniel. So we had a lot of results. Here only an example of a graph about the correlation between some device called NUTRI-KNOW with, in this case, is nitrogen. And it seems that the correlation is very good. And so it's possible to have a good screening, fast results, to know which are the nutrient soil condition for the farmers. It's not to change the way that we need also the results from the laboratory, but it's necessary to improve this device that to obtain that they have more innovation and to explore more research in having in the market more device like this. So next one, please. Then another activity that is a good example of that the activities that was done in Ferticop was the activity 5, that was evaluation of ammonia emission and greenhouse gases during the storage of a slurry and other fractions extracted from it. It was that pilot test was done to measure the effects of covering manure ponds with floating hexagonal plastic pieces that helps to reduce the emission. In fact, the farms need to have the slurry in ponds, and obviously there are emissions, and it's very well known that some kind of materials to cover these ponds can help to reduce the emissions. So next one, please. The test performed by the Technological Center was using the Limbal Hood method, that is in order to capture and measure the gases during the test. Well, I have to recognize that I don't know very well this method, but the results, next one, please. The conclusions after a lot of tests that we can see here, for example, that the temperature obviously is affecting the emissions, and we can compare the emission of ammonia, the difference between covered or not covered ponds. As you see, the emission is higher for not covered, And next one, please. So we saw that the result is about 50% less in the covered ponds, and that a recommendation that we had to comment is that we need to cover up very well all the pond with the floating pieces, and that is not always very easy. And that's some idea that the partners were very interested in exploring further tests with an alternative materials to cover the ponds, because maybe the plastic is not very, they are expensive and is not a sustainable material. And I think that it's all from my side, and obviously I free to receive if you need more information about the result of Verticop. Obviously you can contact us, for example, through the NUTRI-KNOW contacts, or even from the operational groups, the portal from European Union. We can see also have information from Verticop operational group. Thank you very much.
So Giuseppe, you can take control of the slides again.
Okay. Thank you, Marius, to have show us your experience and your activity of the engaged Verticop operational group. Now there is the second operational group, gas loop. What is the problem addressed by gas loop? The problem is ammonia emissions from pig livestock in the Po Valley, particularly in Emilia-Romagna region. The Emilia-Romagna region is in the Po Valley. As you can see from the satellite image, the Po basin area is among those in Europe with the highest ammonia gas concentration for emissions from human, from livestock, from activities, and because the weather condition and the climate is not favorable for the dispersions of these pollutants. Ammonia causes health problems in livestock farm, odors, and it is an important precursor of the fine dust. Okay. The goal of this innovation is to transform ammonia emissions from a problem to a fertilizers resource, and to generate a nitrogen virtuous cycle, a loop, in the pig farming, which, producing ammonium sulfate recovered fertilizers by capturing ammonia emissions, can also replace the chemical fertilizers, and so avoid the greenhouse gas emissions derived from the production of these chemical fertilizers. Particularly, the goal are to develop a pilot able to clean the air and to recover ammonia from pig livestock with a technological maturity level equal to 8, to avoid ammonia emission and enhance indoor air quality for human operator and animal, produce a recovered fertilizers, the ammonium sulfate solution derived by this treatment, in a view of the nutrient recovery and circular economy, and increase the animal welfare and productivity. This is the figure of the pilot plant installed in a fattening pig livestock in Emilia-Romagna. In this pig livestock is produced heavy pigs for the Parma ham DPO value chain. This is the device, a simple device, and this is the scheme and the layout of the running equipment. The device here draws ammonia rich high from the pig rooms through suction ducts located below the slatted floor, where there is the pit to collect pig manure. In this way, the emission from the slurry don't rise and pass through the slatted floor into the room above, but are sucked up by the treatment systems. The air treatment is based on the chemical absorption of ammonia by countercurrent acid washing into a tower. The process takes place at pH from 4 to 5, and a sulfuric acid solution is used as absorbent matrix. Ammonia as a base is salified by the sulfate ions, and in this way a liquid solution containing ammonium sulfate salts is produced. During the cold seasons, a quart of the treated air without ammonia is recirculated into the rooms in order to not dissipate the heat, while in the hot months during the summer and the spring, the treated air is exhausted outside. As we can see in this figure, in this graphic, the ammonia concentration in the treated rooms compared to the near identical but not treated rooms is reduced by value from 57 to 67%. The blue line is the ammonia concentration inside the untreated room, while the red line is the ammonia concentration in the treated room. Especially during the winter time and when the heavy pig, the weight of the pig are higher, this treatment is very, very efficient in reducing the ammonia concentration in the room. The treatment systems during the monitored year made it possible to recover 14.5 kilograms of nitrogen per year per ton of live weight, and so avoided emissions for 17.5 kilograms of ammonia per year per ton of live weight. And if translated on the animal place per year, are near to 2 kilograms of ammonia per animal placed avoid in ammonia emissions. These ammonia emissions are recovered as an ammonium sulfate solution. In fact, 1 ton of live weight reared are able to produce between 230 and 300 liters of solution with an average content in nitrogen near to 5% and in some cases over than 6%. This solution complies with the European regulation on fertilizers and so can be applied in the same livestock farming or also exported to other, for example, farmer or farms without livestock that they have, for example, to buy nitrogen chemicals from industry. The innovation not only reduce ammonia emissions, but also enable the recovery of this solution, and in this way decrease the carbon footprint of the meat produced by the livestock. The animal welfare and productivity are also investigated, and this table shows how the main productivity parameters are better for the pig grown up in the treated rooms compared to those grown up in the control rooms. For example, the daily growth of the pig in the treated rooms are higher compared to the control rooms. The feed conversion index was better, 3.75 kilograms of feed for 1 kilograms of meat, compared to 3.84. Also, the feed yield was greater, and in particularly in the treated rooms with the treatment and the recovery of ammonia. At the slaughterhouse, there was an absence of lung injuries of 45% compared to 37%. This data is very, very important because in this time, in the Italian slaughterhouse, when the pig arrives without lung injuries, keep a bonus, a big bonus, especially after the coronavirus. At the end, in conclusions, Gasloop has shown that a PAT, a base available technology, applied to reduce ammonia emission, can also recover nitrogen and produce a benefit. Their treatment with ammonia recovery as fertilizers was technically feasible, and for example, in a pig farm with a total live weight of 1,100 tons, can be recovered nitrogen for 16.8 tons of nitrogen per year. The ammonia concentration in the rooms is reduced, and so are reduced the ammonia emissions to the air. The better animal welfare produce better meat quality and also pig yield, but the impact on the pig production cost of the innovation for reducing ammonia emissions is problematic. Cost increase of 7.3% for kilograms of meat produced. Today, the value of the live weight heavy pigs for the DPO Parma ham is between 2.1 and 2.3 euro per kilograms. As is often the case, system to reduce environmental impact produce more cost for the farm than economic benefit. And so the funding support may be welcome to make this innovation more diffused in the livestock farming. For me, is all. Now I can pass the speak to John Hendrick from Chagas, from Ireland.
Feel free to take control now, John.
Thank you very much. You're hearing me okay, I hope?
Yes.
Yeah, that's good. My name is John Hendrick, and I'm from Teagasc in Ireland, and that's the Agricultural and Food Development Authority. And it's the national body that provides research and advisory and training services to the agriculture and food industry in rural communities. And as part of this webinar this morning, I'm going to speak on two of the operating groups which are linked with the NUTRI-KNOW project. And just for anybody that wishes to learn more later on, if you can go onto the NUTRI-KNOW website, you can click on the livestock farming image seen here that I'm pointing at, and you will find resources, informations, and fact sheets and all the rest on all of the operating groups that I'm going to speak about and that the rest of the speakers have been talking about this morning. So the first of the operating groups that I'm going to talk about is, biorefinery glass. It's a small mobile biorefinery plant it's operational group 10 in the NUTRI-KNOW family, and it's based in Southwest Ireland, down here where the pin is. And as I said, it was based on a pilot scale in collaboration with a number of local farmers. And the aim of the biorefinery glass plant, which is here, as you can see, it's on a lorry truck, so it's easily transported around from farm to farm, making it a resource that farmers can use at different times. It's not a case of having to bring the grass to it. And it processes grass into 4 products. And these 4 products refine out unused nutrients and that are not normally processed or used when grass is used in the traditional way of being used as grass silage or even fresh fed feed to animals. So once it goes through the process of extruding from the grass, so the grass is split into 2 fractions. There's a solid dry fraction when the machine squeezes it and takes out a liquid and a solid fraction. And the solid fraction is a high fiber press cake. And that's about 50% of the weight of the grass that originally goes into the refinery. This liquid then can be refined further to make further alternative animal feeds and other products which can be sold and add value to what the grass value is initially. And the real take-home message is, by using this biorefinery process, it's going to increase the usable protein per acre that is produced on farm by 40%. And it's also going to, at the same time, reduce the nitrogen and phosphorus losses per hectare by 25%. So what is press cake silage? It's an alternative feed from grass. As I said, it's the high fiber part of the grass after it's processed. So grass silage was supplemented in a trial in conjunction with UCD, the biorefinery glass operating group. UCD did a trial in Dublin on early lactation Holstein Friesian cows. And grass silage was supplemented at different rates, but at the rate of 30% of the grass silage being supplemented by the high solid fiber press cake, it showed a nitrogen use efficiency increase in the animals. It shows an in vitro reduction in methane concentration in the rumen, so emissions were lower from the animals. And it also showed that nitrogen and phosphorus excreted by the animals was lessened. Again, you're increasing the grass value. So where are these reductions coming from? Well, the part of the grass that the cow is unable to normally process. Normally the ruminant eats grass and takes from it what it can. But when the solid fiber press cake is processed in the biorefinery glass process, it leaves all that the cow needs for its diet in the grass. So in that trial with UCD, there was no effect on milk production quality or volume. And as I said, there was a reduction in emissions. But the liquid fraction that was removed that the cows aren't getting access to, but it doesn't affect how the cows are performing, that can be refined down further. And one of the alternative animal feeds that can be produced from that liquid is a high protein pig feed. When I say high protein, it's actually 33.9%, so 34% protein for an easy number to remember. And there was a trial done on a piggery in the southwest of Ireland to assess to see how this performed in comparison to the traditional diets, which is imported soya. So replacing 50% of the soya in the diet with the high protein pig feed from the biorefinery process. It showed in the test group, after an initial 7 days of a changeover period for the animals to adjust to the new diet, it showed a higher than average daily intake, as well as a higher than average daily gain within the pigs in the experiment. And the implications of this, apart from obvious economic benefits to the farmers in that you're getting a higher daily gain and a daily intake increase, it's also reducing transport distances and import costs, because the soya that's traditionally fed to pigs in Ireland, or many of the animals in Ireland, is coming from South America. So you're going to have reduced costs, reduced transport distances, and following on from that, the reduced emissions, because if the protein source that you're using to feed your animals is coming from the local area, from a local mobile biorefinery that's processing it and it's easy to source, as opposed to across the Atlantic Ocean. So you're increasing farm efficiency and income as a benefit from using the high protein pig feed. So there's two other product streams that come as part of the biorefinery process. So you have your alternative feed, your high fiber solid press cake for the ruminants, you have your high protein feed for the pigs, but also there's high value sugars. Now they're called fructooligosaccharides, and they can be used as prebiotics in animal feeds. And they're high value, but in the traditional, all of these extra product streams that can come from the same grass that was initially being fed for cows are now being valorized. So you're increasing the value of the grass that's being produced. You're opening up new potential income streams for farmers to be able to take advantage of. So the last product, so the grass is squeezed and then it's processed and they take out the protein feed for the pigs, then they take out the high value sugars, you're left with a liquid. What is this liquid? Well, this liquid is seen in the picture there with the green arrow on the left-hand side. It's a bio-based fertilizer and it's called grass whey. And this grass whey has comparable nutrient values to traditional slurry, the slurry that the cows would have produced if the grass hadn't been processed. And as I said initially, this biorefinery GLOS operating group was operating at a pilot level, and now they're into the future. The plan, well, funding has been obtained to integrate the grass biorefinery with anaerobic digestion, and that's going to be part of the rural biorefineries, it's called. And this project focuses the next step on, in that it's focused on high value products. So it's going to be food, feed, and cosmetics, and possibly biogas and biogas with fertilizer as well. And that's going to run from 24 until 28. But as I said initially at the start, if there's any further information that you want, reach out, contact us or any of our partners, or go on to the NUTRI-KNOW website. There's a resource there with further information and all the information sheets regarding to biorefinery GLOS. The next operating group, it's based in Ireland as well, but it's...
John, just before you continue, I think there's a question directly relevant to what you just presented, a question by Tatiana, which is what part of the ruminant's diet do you replace with this silage feed pellets?
So, sorry, Tatiana, yes. So the control was silage, just traditional grass silage, and the replacement was 1/3 of the silage that was offered to the ruminants' diet. So you would have grass silage, and it was a mixed ration actually. So they had 7 kilograms of concentrates in both of the control and the experimental group, but it was the silage, the traditional grass, baled grass silage was replaced at a rate of 1/3. That's what it was. So I hope that answers your question, Tatiana. Should I continue on, Daniel?
Yes, please.
Okie doke. The next group that I'm going to talk about is an operational group in Ireland as well, but it's just over along the coast, and again, more resources on the website. And that operation group was focused on farming practices to enhance water quality. Now, the Duncannon Blue Flag and Farming and Community Scheme, it's down here. So it looks like it's only over the road from the other operating group, but it's a bit of a drive. And this EIP operational group is a collaborative group. And it was a combination of local communities, local government and farmers coming together to try and solve a problem which came to a head in 2007. If you look just on the dot there, there's a beach, and this is Duncannon Beach. And in 2007, it lost its blue flag status. Now, that had an impact on the area because Duncannon Beach is a bathing and shellfish water. And the community, the local authority and the farmers came together. And as part of this, the black line in this picture on the right shows the catchment area of ground, land and housings that was deemed to be affecting the streams and the water courses, which are marked very badly in blue by me there. But so action had to be taken to try and improve the water quality to restore the quality of the bathing water in Duncannon. Now this group ran from 2018 to 2023, and the partnership went forward. Now I'm missing my animations, but we'll go this way. We'll use the pointer. So there's within that area on that last picture that I showed you on the black line, there's 975 hectares were identified, and in that 975 hectares, it was decided that changes had to be made. It could aid the quality of the water if changes were made by the farmers that were operating businesses on it. So the 35 farmers were identified. Now, of these 35, 8 of them were arable farmers, 4 of them were dairy farmers, and the balance, the 23, were dry stock farmers. Now, these farmers were approached, and they were all appointed a sustainability manager. The sustainability manager was somebody to act as an intermediary with the farmers to provide information to help them in the process that they were getting involved in. And what was this process? Well, the process was the drafting of pollution potential zone plans, it's called PPZ plans, essentially an assessment of what was happening on farm level that was impacting water quality. And as part of that assessment, there was then solutions to reduce and improve the quality of water, to reduce the effects that agriculture was having on the quality of water in the area. And again, then implementation happened on the 975 hectares. And this is what led to an increase in water quality. Now, the PPZ maps, it wasn't just a case of going to the farmers and saying, do this, please. There was a results-based reward scheme put in place. And the simple way of explaining it is there was a score sheet. And on that score sheet, it was identified where the PPZ zone, so where the pollution potential zone was. So it could be a case of there was direct discharge of runoff from incorrect water separation on farmyards. It could be water coming off livestock car roads or paths. It could be animals accessing waterways. And these were all graded on a scale of red, yellow, or green. And the incentive for the farmer was a financial one. If they could change the practices on farm and get their potential pollution zones into the green, then they could benefit from a payment of so many €1,000 per annum, just for doing things to protect water quality. And it had to be in collaboration, of course, with this scheme. So some of the actions, the implementation actions that were taken at a farm level are listed here. And the first one is water courses. There was over 15.5 kilometers of water courses were fenced. This was to exclude livestock from them for the simple reason it's going to firstly reduce fecal contamination or potential fecal contamination to water courses. And it's also going to help reduce erosion and increase ecological quality, because there is that buffer between the farmland and the river. Drinking points, as seen up in this picture here, they were moved away at minimum of 20 meters from all watercourses. Again, for the same reason of reducing fecal contamination and reducing potential runoff and nutrients getting into the waterways. All the farms were soil sampled. The soil sampling, they went out, soil sampled all the land, analysed the results, and nutrient management plans were drafted for all of the farmers. Nutrient management plans were simply a balancing of the books, a balancing of the nutrients that are available in the soil, the nutrients that the crop you're going to grow require, and how much nutrients or perhaps no nutrients you need to apply of certain types, dependent on the amount of organic nutrients that are available on farm, or in some cases with the arable farmers that didn't have any. But this was key, the nutrient management planning and the soil sampling. Buffer zones were implemented along by watercourses of 10 meters, reducing the erosion potential, increasing the local flora and fauna, but also removing the application of nutrients close to waterways by a further 10 meters. Because there is that buffer, it reduces the potential for leaching into waterways. In the case of erosion, runoff, or animal paths, sediment traps were implemented to catch the water that might have suspended solids that needed to be intercepted before it got to the waterways and cause the pollution in the waterways. And all the organic slurry that was on farms was spread with low emission slurry spreading systems. So that would be direct injection or trailing shoe onto the actual land. Riparian zones, as I said, they were planted in native plants. So this is just a buffer along by the river as well. Hedgerow planting to help retain nutrients and to reduce potential erosion of soils and damage to soils. Arable grass margins, there was 1.2 kilometers of these implemented. Again, it's moving the nutrients that are being applied back that little bit from potential areas, from the potential pollution zones. You're trying to reduce the amount of nutrients and the effects that agriculture is having upon the waterways by just giving it a little bit more space. It sounds very simple, but it does work when put in practice properly. And finally, the last one was winter cover crops. Yes, winter cover crops provided 3 benefits to the farmers involved. Firstly, is help to comply with the nitrates directive and the greenings, having to have the green cover over certain winter months. It also helped that the winter cover crops were taking the available nutrients that were there at a time of year when there was no crops actively growing that farmers were wanting to be in the soil or couldn't be in the soil because of environmental conditions. So they would take the nutrients from the soil, store them over the winter, and then in the spring they would be reincorporated back into the soil, returning the nutrients for the following year's crops that the farmers are wishing to grow, but also improving the quality of the soil by increasing the organic matter in it. And the last one then, the cover of having winter cover crops on is a far better option than having exposed soils, which can be exposed to potential erosion events or loss of sedimentation of water and into the waterways, and then you're running into more issues with water quality. So, too many clicks. So what was the results, benefits and performance in regards to what was undertaken by the Duncannon Blue Flags and Communities scheme? Well, firstly, there was a reduction in bacterial pollution in the waterways, which initially, when the blue flag status was lost, the water quality in Duncannon was classed as poor. It's a 4-tier grading system of poor, sufficient, good, and excellent. And as I said, in 2007, it was down to poor. By the end of the blue flags scheme, it was after getting all the way back up to good. So that was a massive improvement to everybody involved, not just the farmers, but also the community, because of the benefits of having a bathing area that could be used safely. There was an improvement in ecological quality throughout the 975 hectares. There was efficiency increases on farms, particularly in regard to soil testing, nutrient management planning, and the health of animals, because having animals, simple thing of having animals restricted access or not allowed access to waterways, you're reducing the potential for a biohazard that could affect the animals from further upstream. But the one thing from this collaborative operating group that has been seen is there's a definite importance of staffing. When I say in regards to that, the farmers and the community and the local government were all involved in collaboration, but key to that was the advice and the support that was available from both independent advisors, Teagasc, and from the sustainability manager. It's just having that conduit that information is able to flow through for farms. But overall, this operating group has shown that this kind of collaborative process will increase water quality by changing livestock practices. That's it for me. So I'll hand you back to Giuseppe for now. Thank you.
Actually, Giuseppe, I know there are some wrap-up slides, but I think it might be good to use the remaining few minutes to answer some questions from the audience and also give over to the audience. There are two questions. There was a question asked twice that goes towards you, Giuseppe, I think, which is the basically how valuable is the ammonia sulfate fertilizer on the market? Is it sold commercially by the farmers, and what, if you know, is the price per ton?
Now in Italy, the ammonium sulfate recovered is at the beginning of the market steps. And so there is a strange situation. The farmer requests this ammonium sulfate solution, especially to be applied in fertirrigation system with drip lines, because they are useful for tomatoes, for oracles, and so on. But the producers of this ammonium sulfate at the moment are not at a commercially point stable. They are not able to sell every week the same quality or the same amount of ammonium sulfate. But the ammonium sulfate produced in this activity, as I told, it is compliant with the regulation, the European regulation, and so can sell. But I believe that farmer is too small to sell directly to the final users, and so are needed an intermediate as the fertilizers producer, because I believe in these steps. The business of the farmer is not produce ammonium sulfate, is produce meat or milk, and this ammonium sulfate has to be the business of the fertilizers company.
Thank you, Giuseppe. There's another question that probably goes towards all the speakers. It's in the case of the Netherlands, there's a nitrogen mineral fertilizer ceiling of 170 kgs per hectare. And the question is if this is also applicable irrespective of the mineral fertilizer. So if you use the valorized recovered fertilizer, does this still apply, or can you then apply more? Not sure if any of you would know this.
Well, I can't speak directly for Holland or the Netherlands. I know that, yes, some of the fertilizer, it's a changing landscape at the moment with regard to these fertilizers, but unfortunately, no. As far as I'm aware, the 170 kilos, which is applicable here as well, nitrogen is nitrogen once it's applied. So it all adds towards the one bottom line. at the moment. So I don't foresee changes in that myself personally. I don't know, but that's my read on it at the moment anyway. There's another question there, Daniel, with regard to capital expenditure.
Yes.
And the operating group, biorefineries, glass, there was low capital expenditure. It's a low capital expenditure in relation to a traditional biorefinery. I haven't the figures to hand, but because it is mobile, it is envisaged to be used by multiple farmers and go around from area to area as part of a cooperative group. And like the operating groups that we're dealing with in Ireland, they are on pilot levels. So figures, while I appreciate they would be very welcome, they're at the stages of getting them together. But in regard to biorefinery glass, would the juice be worth the squeeze, if you pardon the pun? Quite literally, I think it looks very favourable that it would be, because you'd be utilising a resource, your grass, and you're still getting the very same benefits from the grass by feeding it to your animals, but you're making a further 3 products which can be valorized. So it's not just, I know emissions are very important and you mentioned them there in your question, but it's also extra income streams and potential new incomes that are being investigated in for farmers. So it's trying to balance both sides of the equation. It's, yes, emissions are important and controlling emissions are important, but it's also the realism of businesses are being run and economics comes into the equation as well. So those figures were being worked on. Back to you, Daniel.
Yeah, Giuseppe, do you maybe also have a comment maybe for Gasloop on the financial side? If there's anything you can say about that?
The financial about the equipment of Gasloop.
Yeah, and how high are the costs to get the technology, and when is it maybe refinanced?
At the moment, how is often happen in all the Europe, I think, the nitrogen cost for kilograms, for example, of urea are not so high. And for example, the cost of urea is low per kilograms of nitrogen. Instead, the cost of kilograms of nitrogen derived by this equipment is more higher than the cost of nitrogen produced by urea. For example, it's the same case for the fuel. It's cheaper use natural gas or fossil fuel that, for example, electricity for biogas and so on. This is the one problem. The other is that the based technology to reduce ammonia emissions in the livestock farm are applied only if mandatory. They are not so incentivized or funding. And so at the moment, the livestock farm apply other technology that better fit the cost benefit for the mandatory level of the industrial emission directive. For example, the higher treatment from pig stable at the moment is expensive. And so the pig farmer applied BAT related to the storage, for example, covering the storage, or for slurry application in the soil. Make modification of improvement in the building is more difficult.
Thanks to Jeppe. I think, Prema, I hope I'm not mispronouncing your name. Probably I am. But I think it's a great question that we will carry over in the future webinars to know more about the financial investment and operational costs and that sort of thing. Maybe a question for all speakers about the feasibility of all of these technologies and practices that were now presented. How feasible do you think it is for farmers to change their current systems and incorporate what you've just presented?
Okay, Daniel, if I can say something about these farmers have at Catalonia, I don't know if in the rest of Europe, a lot of problems to sell their products, to produce. The costs are even higher every day. So as I said by Giuseppe, that if it's not mandatory, something, it's difficult to make investments. So we need to collaborate, the governments and institutions and companies, cooperatives, and so on, in order that the investments to do to use the best technologies that already exist, as we have seen with, for example, with the tests that we can make in the fields, or that are not very expensive sometimes, but at the end the farmers don't applicate these innovations, and there are a lot of stress from commercial companies that need to sell something, innovations, but at the end, I think that the farmers are still with the same technology, and it's difficult to improve the situation. And according to the Ferticop project, we didn't have any assessment of cost or figures. If I remember, there was not a very detailed study about the cost of the innovation.
There's one other quite interesting question by Neil is if farmers would adopt our innovations, would the price for the consumers increase? So if they have to invest, would they shift also this investment towards the consumers? Do you maybe have some insights on this question?
I hope yes, if the costs are higher, we need to change the price of the products, the final price. But I don't know if it's possible always to do that.
And it's like what you were saying about the comparison of using the recovered fertilizers or using or using fuels like diesel as an alternate. It all comes down to the economics. So passing on the costs of producing these extra products is ultimately going to be determined by what the market price is, and the potential for these producers of new lines or new streams of potential income. It all comes down to the bottom line of what the other resources available within the market that are doing the same are priced at. Once they are finite, they're resources that are reducing, so their prices will go up, and these processes will be put in place. They will become definitely economically viable.
Yeah. Maybe one last question, and then we will close the meeting to John. I think this refers to the Duncan Beach OG, does the farmer assume the costs of the needed changes? And is then this cost compensated later on once the pollution risk goes down?
Okay, so I see further there, was it only an experimental setting, or is this a policy in the region? Okay, in the Duncannon Blue Flag case of the Duncannon Blue Flag, you could say it was experimental because it was trying to reduce the pollution in a specific area by farmers, communities, and the local government. Now, the communities and the local government did changes in investment on their side, as did farmers. But the costs were borne by the farmers themselves. No, they were not compensated if the pollution level goes down. But the reason why the farmers had to take those costs on themselves, the majority of what the farmers had to do were in line with compliance with the nitrates directive nationally in Ireland. So in putting up fencing and incorporating multi-species swards into their farming practices, they have to do that to get their basic income support for sustainability. It's part of the requirements of farming and getting payments from the European Union. But in this case, there was the incentive of financial gain by putting these in place a little bit quicker, so that the project could be assessed to see, does it benefit? How quickly can we change this if this is done? So no, it is not a policy in the region. It was only on that experimental trial, and farmers, but other farmers across the country and around Europe that have to put these same practices in place. This project has shown that there is savings in both financial and resource use and resource management can be made by implementing these changes. They're not very capex heavy, fencing and intercepting water and leaving buffer zones. It's very low capital expenditure for these things. Hopefully that answers the question.
Yeah, thank you, John. And with that, I would like to close the meeting. Sorry for going a little bit over time, but thanks to the audience for being there. There's just one last survey that I would like to just copy and paste in the chat. A little evaluation of the webinar. Feel free to click on it, answer a few questions. It will only take 1 minute. We always try to improve these webinars and make the best out of them. If you have any further questions, feel free to contact us. All of our contact details are on the NUTRI-KNOW website. And yeah, with that, thank you to our speakers, John, Giuseppe, and Marius, for being here today and presenting the innovations. And thanks to the audience. And
Daniel,
goodbye.
Also,
Giuseppe.
I think with perhaps there was a little time for discussions. On the NUTRI-KNOW website, there is the community of practice, in which all the user can produce knowledge, can make questions, and moreover, and so all of you can log in the community of practice.
Yeah, it's thanks, Anna, for the link in the chat. So we have our community of practice in NUTRI-KNOW where you are able to register and ask questions that will be answered by experts. So it really is there for exchange of knowledge. So feel free to give it a try. And we have a hand raised by Kevin. Kevin, go.
Yes, sorry, just a quick question, because it says that the session is recorded, and I was just wanted to know if it's available then later somewhere on your website or platform.
Yes, it will be made available on the website.
Okay.
As well as the slides.
Okay, thank you.
No problem.
Thank you for the presentation. It was very interesting. Thank you.
Thanks, Kevin. So then I would wrap up the meeting. Thank you all for being here, and hopefully see you in one of the next webinars. Bye-bye.